Hello, Algebra 2s. Here's a review of last class's lesson, which is where we were solving quadratics by using the square root method. So we can use a bunch of different methods when solving quadratics. We talked about factoring last time. So this time we're going to talk about a second, which is taking the square root of each side. And this happens when you have a perfect square in your equation that you can isolate on one side. So see, in this one I divided by 3, I divided by 5. So even though there is an algebraic expression here, these parentheses wrap it up and make it so that it is an expression to the second power. So this new property of equality that I can do is take the square root of each side. And if I have a perfect square here, then taking the square root will eliminate this exponent. So taking the square root is the inverse operation to squaring something. The most important thing I have to remember is this plus minus, because when I'm talking about what number when squared could give me 9, it could be either positive or negative 3, and that's those two answers. And that same understanding of is if there's a positive or a negative value inside here, we can still get this answer. And then when we eliminate that exponent, we have to still remember to solve for x by adding 1 to each side. So we can have the same problem solved in our two different ways. So far we've talked about factoring, which is where we set it equal to 0 and then factor, and then use the zero product property to go ahead and set each of these expressions equal to 0 and find the value that makes that true. What we're doing with the square root method is instead of setting it equal to 0, we're just going to take the square root, remembering both the positive and negative potential values for x, and getting that same answer. The only conversation we need to have is what happens when what is underneath this radical sign has a negative value. And you need to just remember, if you're taking the square root of a negative number, we're going to bring in imaginary numbers. Mathematicians made this up. So the square root of negative 1 is I, and I squared is equal to negative 1. And if we talk about where this fits into our system of numbers, our real numbers here that you've been learning about since you've been in school has your rational, irrational, integers, whole numbers, and natural numbers. But now we have this idea of imaginary numbers, and then when we put them together with a real number, we get what's called a complex number. So we solved the first couple of these in class together last week, but I'm going to continue working through this so you have these examples. All right, my first job is going to be to isolate my square. This is what I want to get by itself. So I have to undo what I see going on. This is a positive 6. So if I subtract 6 from each side, I can eliminate this constant and join him with his buddies over here. So I have negative x squared divided by 8 is going to be equal to, and then I have this negative 10, negative 4 minus 6 more. Now I'm going to address this 8. If I multiply each side of the equation by a negative 8, these two negatives will cancel out. This 8 and this 8 will cancel out, giving me x squared is equal to positive 80. So now when I take the square root of each side, I have x is equal to plus or minus the square root of 80. I'm not satisfied leaving this alone though, because I know 80 has perfect square factors. So let's break that down. 80 breaks down into 8 and 10. 10 is 5 and 2. 8 is 4 times 2. Here's a perfect square, and here's a double factor. So they both come out of the radical sign, giving me x is equal to positive or negative. Take the square root of 4, I get 2. This double factor is 2, so 2 times 2 is 4, and that's times what's left. This guy is left, square root of 5. All right, let's look at this one. Here is my squared term, so this is what I'm going to get isolated. On one side of the equal sign, I got to talk about this negative 2 So minus 2 from each side gives me 1/3 of x plus 5 squared is equal to positive 7. I'm going to multiply each side by 3. This 3 over 1 is going to cancel out that 1/3. And I have x plus 5 squared is equal to 21. Now that I have my square isolated, I'm going to take the square root of each side. And I recognize that x plus 5, I don't write the squared anymore because that square root and that square are inverse operations, plus or minus 21. Square root of 21. Careful. 21's factors are 7 and 3. I can't simplify that at all, so when I go to solve for x, I'm going to subtract 5 from each side, and that's going to be plus or minus my square root of 21. It's not a pretty answer, but it's the best I got, because I want to make sure that you recognize that I have two possible answers, the plus and minus, and this is an irrational number. Okay, note, how many solutions do each of these graphs have? So each of these graphs all have two solutions. They have the plus and the minus. The positive and negative, positive and negative. All right, let's talk about number 5. So my job is going to be to get this squared expression by itself on one side of the equal sign. So I'm going to add 5 to each side. That's going to give me negative 1/2 times x plus 8 squared is going to be equal to positive 14. Now I have to deal with this coefficient next. So I'm going to multiply each side by negative 2 over 1. These cancel out. My negatives cancel out. So I have x plus 8 squared is equal to negative 28. When I take the square root of each side, I get x plus 8 is equal to plus or minus the square root of negative 28. So this negative sign has to come out as I, because the square root of negative 1 is equal to I. And then I have to talk about 28. If I break down 28, 28 breaks down into 7 times 4. And of course, 4 is my best friend. He's a perfect square. So let's talk about this all at one time. X is equal to, I'm going to subtract 8 from each side. And he's going to plus or minus. This 4 comes out of the radical sign. My I is there. And 7 is left inside. That's a lot going on that answer. So we need to make sure we understand where all that came from. This 8 I subtracted from each side. And usually when you write complex numbers, you put that whole value first. So subtract 8. Here's my plus or minus, because when I took the square root, this could have a positive or negative value. When I break down 28, I see a perfect square factor. Oh, wait. This is supposed to be a 2, because square root of 4 is 2. Square root of 4 is 2 when he comes out of the radical. Square root of negative 1 is I. There's his part there. And the square root of 7 is left. All right, let's keep going. Here's my perfect square that I want to isolate. So that 4 has got to go. And that's going to give me x minus 2 squared is equal to positive 36. When I take the square root of each side, the square root of anything squared is that thing. So I have x minus 2 is equal to plus or minus. This I can simplify to 6. So I have to get x by itself. I'm going to add 2 to each side. So I get x is equal to positive 2 plus or minus 6. Here comes the tricky part, and I want to make sure you can understand this. This is actually two conversations. This is 2 plus 6 and 2 minus 6. So when I'm talking about the values of x, x can be equal to 2 plus 6 is 8. 2 minus 6 is negative 4. Those are our answers. All right, conjugates. Anytime there is an imaginary answer, it's conjugate, which is going to mean its opposite. is also an answer. So the conjugate is kind of like its opposite, is also going to be an answer. So let's go back up and look at solutions for number 2. We're going to have plus positive 1/2 I and negative 1/2 I. Look at number 5. I have negative 8 plus 2I root 7 and negative 8 minus 2I root 7. Imaginary or complex solutions always occur in pairs. All right, this next section. Decide what's best, the best method to solve the quadratics, and then solve. All right, so when we look here, I want to say this is the difference of two perfect squares, but it's not, because 2x squared is not a perfect square. So then I have to look and say, okay, well maybe I can just take the square root of each side then. I'll add 25 to each side. I'll divide by 2, and I end up with x squared is equal to 25 halves. And then I can take the square root of each side, and that's going to give me x is equal to plus or minus the square root of 25 over the square root of 2. I can break that up. So square root of 25 is equal to 5. But the square root of 2 is not allowed to be done in the denominator, so we have to do a process called rationalizing the denominator. So we end up with x is equal to plus or minus 5 roots of 2 over 2. Because the square root of 2 times the square root of 2 is equal to 2. So there's our two answers, and we're good to go. All right, let's check out this next one. I need to, maybe factoring will work on this one. 3x squared minus 33x plus 72 is equal to 0. Let's go ahead and divide everything by 3 and see what happens. Because if I have x squared minus 11x is equal to 72 divided by 3, let's check that out. 72 divided by 3. So 3 goes into that 24 times. So I'm already excited because I'm spinning the numbers around in my head. And I know that x can split, x squared splits into x and x. If I'm looking for, oops, it's supposed to be positive. If I'm looking for two numbers that multiply together to give me positive 24 and add together to be negative 11. So then I've got x minus 3 could be equal to 0, x minus 8 could be equal to 0, x is equal to 3, and x is equal to positive 8. So that factoring problem worked out better for me because my x squared, and I had a term there. So taking the square root was not an option for that one. Okay, let's check out this last one. Taking the square root is an option for this one because look, I have this perfect square here. So let's go ahead and add 3 to each side, which is going to give me 20. So then when I take the square root of each side, I have x plus 1 is going to be equal to plus or minus the square root of 20. So when I look at 20 and its factors, I know 20 breaks down into 4 and 5, and that's a perfect square. So then I can say x plus 1 is equal to plus or minus square root of 4 is 2 roots of 5. Then I'm going to subtract 1 from each side, and I have x is equal to negative 1 plus or minus 2 roots of 5. All right, those are the notes. Good luck with the homework.